Hello, we are presenting our CE465 project, SunnySense. As an introduction, this is a cloud-connected weather sensor that can get values about humidity, temperature, and ultraviolet radiation. This sensor can be used for many different uses, including personal monitoring, recreational planting for someone who likes to garden, or farming as a whole for someone who has to plant a lot of things on a large scale. For overall design, we start with an ESP32 as our microcontroller of choice. To this controller, we have two sensors. The first is our humidity and temperature sensor, and our second is our ultraviolet radiation sensor. Both of these are connected to the ESP32 through GPIO. From there, we use telemetry to send data from the ESP to Azure IoT Hub. We use a stream analytics job to send the readings from the IoT Hub to an Azure SQL database. From there, we have an HTML website that's hosted on GitHub that uses SQL queries to get data from our database and display it on the website.
Our project uses two main sensors, the first of which is our temperature and humidity sensor. This DHT22 module digitally collects temperature and humidity data and transmits it over a single line to our ESP32 via GPIO pins. Our other primary sensor is the UV sensor, the GUVA S12SD from Adafruit. This sensor is analog and uses a UV photodiode to capture UV rays and transform that into voltage. It's connected to the ESP32 via GPIO pins, which then are interfaced to the ADC to create a digital output from the analog input.
We 3D printed an enclosure for the SunnySense that protects the electronics from the elements while still exposing the sensors to the outside. The SunnySense will need to be connected to an external battery and a Wi-Fi network to transmit data. Our device sends its data to the IoT Hub via telemetry. The ESP32 microcontroller uses the Azure for C library as well as the MQTT protocol to send its messages. The stream analytics job on the Azure portal stores the real-time data in a SQL database that our web interface can access. And it also includes running averages of the data as an aggregate. For our web interface, we used a web page hosted on GitHub that displays both the current sensor readings as well as the average sensor readings over a period of time. It also includes links to all of the code used in this project, and it utilizes a Python API that exposes our Azure database via SQL queries. And now on to the demonstration.
So here we have our ESP32 wired up to a breadboard along with two different sensors. The first of these sensors is a UV sensor to detect the UV level from light outside. The second sensor is a temperature and humidity sensor, getting values about the temperature in Fahrenheit and the humidity at the percentage. This sensor is connected with a pull-up resistor, and they're both connected through GPIO because they have analog inputs, and the ADCs allow it to convert to a digital signal for the ESP32 to read. From there, the ESP32 sends that data through Wi-Fi over to our IoT Hub. As you can see, the messages containing temperature, humidity, and UEV index are included here, along with a time for when it is sent.
To move the data from the IoT Hub to the SQL database, we use a stream analytics job on the Azure portal. This job transmits all of the readings collected in the IoT Hub to the SQL database.
And the final component for the Azure section of our project is the SQL database itself. It permanently retains all the values that are sent from the device so they can be processed. As you can see, after running this sample query, we can see all the results that we just gathered are showing in our database here.
The front end of our web app is hosted on GitHub, and it displays the current weather readings for each SunnySense that has been implemented, as well as the averages for all of those readings. My SunnySense is currently on my windowsill because I want to know the weather conditions for my plant. This front end that's hosted on GitHub uses a Python API that for now must be hosted locally. Additionally, the links to all of our code for this project are included. Here's the code for the simple front end. It's just pure HTML with a script that fetches from the backend Python API. This is the code for that API. It features 2 different routes to get the most recent data as well as the average data. And here's the code that we used for the SunnySense to both obtain the data from the sensors as well as push that data to the IoT hub.
Here we have the SunnySense attached and fully powered on outside. We can see that we're getting live streams of all the data every 10 seconds in our Azure IoT telemetry. There's our next update.
And here is the web app. The current temperature as well as the average temperature and the rest of the data is displayed. And if I refresh the page, the temperature will be updated to the most recent temperature and the average will be updated with the most recent values.